far this unit we've talked about the intersections of a plane with a line, and we've talked about the intersection of two lines, and today we're going to start talking about the intersection of planes with planes. So to start with, we'd like to look at the following two planes. Plane 1, which is the Cartesian equation x minus y plus z equals 4, and plane 2, which is x minus y plus z equals 5. And we want to ask ourselves, how are these planes related? So if I look at both of these planes, I can pull out the normals of both of these planes. The normal for plane 1 is 1, negative 1, and 1. The normal for plane 2 is also 1, negative 1, and 1. So these look like, or they are, the same normal, which means that these planes are parallel. If the normal of the planes are equal, that means the planes are parallel. And the difference between having either the same plane or just two parallel planes is the constant value. In plane 1, the constant value is 4. In plane 2, the constant value is 5. Visually, what this looks like are two planes parallel to each other with one raised slightly higher than the other. So imagine this is a plane that's been shifted 4 units up. This is a plane that's been shifted 5 units up. And we can say that these planes are parallel no intersection. Well, it's not enough for us to say that they're parallel and have no intersection. We do need to prove it. And we can prove it by using elimination. So if I write both my planes, x minus y plus z equals 4, over top of each other, x minus y plus z equals 5. Remember that elimination is a method where by adding or subtracting equations to each other, we eliminate at least one of the variables. So if I take these two equations and I subtract them, I'll have x take away x, we get 0x, negative y, take away negative y, we get 0y, z take away z, 0z, and here I get 4 take away 5, which ends up being negative 1. This equation ends up being 0 equals negative 1. Remember from the first video, we said that this is math's way of telling us that this situation is false, which means no point of intersection or intersection in general. Second example, if I want to find the solution to this following system of equations, if I want to find how these two planes intersect or interact, I can look at these two equations and I should see that there's a common factor of 4 in all of the terms in equation 2. Which means I can rewrite equation 2 as a factor of 4 divided out of every term . When I divide out that common factor of 4 from both terms, I can cancel the 4 on both sides, exact same equation as my first equation in the system, which means that I can say that both planes are equal. So I have infinite solutions. So when we're working with planes, trying to see how the planes intersect, we want to really start by looking at the normals of the planes. So we can say that the planes P1 and P2 will have normals N1 and N2. If the normals are scalar multiples of each other, then we can conclude that the planes are either coincident or the same, or they're parallel. If the planes are parallel, they'll have no solutions. If the planes are coincident, they'll have infinite solutions. And we can distinguish between coincident planes and parallel planes by looking at the constant value in the equation. If the constant value is the same, they're coincident. If the constant value is different, they're parallel. If we look at the normals, and the normals are not equal to each other, then the planes have to intersect in a single line. So in the video today, we've looked at point 1, being able to tell if planes are coincident or not. We know that if the normals are not scalar multiples of each other, then the planes will intersect in a line. Tomorrow in class, I'm going to look at point 2 and show you how to determine the line of intersection.